Hi, I'm going to go over the project overview examples in this video. So I've already gone over the project overview content and what you need for that. So I wanted to discuss more about the details of the milestones and then give a couple other examples. So the milestones themselves need to be very clear or will be left to interpretation. So that means I get to interpret it and grade you as such. So make sure there's a clear deliverable for each milestone step, and each milestone should contain approximately 100 hours of work to complete. Specify as much information as you can for those milestones. An example milestone: working circuitry to convert a sinusoidal input to a square wave, and it gives the specific frequency and peak amplitude that I expect to get. So this is kind of like a mini task. Again, this wouldn't take you 100 hours, I hope, to be able to do, but is an example of a very clear deliverable with the inputs and outputs to it. Software code that accepts a user input from 1 to 20 and it outputs a sinusoidal signal with its frequency based on the user input. So as you can tell, it's not specific which kind of software language I'm using, so that doesn't matter, but the output is what I'm looking at, that deliverable of this is what the code actually does. So an example: program the Arduino to communicate with the temperature and humidity sensor. Take a second, think about that. Is that a clear milestone? Hopefully you said no, because it is not. It's communicate means what? What am I expecting out from the temperature and humidity sensor? What are my conditions? Am I testing it just once, or am I testing it 100 times over 3 days? So it needs a lot more clarity as far as what this is going to do. So to make this more clear, I could add that it will be connected to the computer and the screen will show the differences in the environment when heat and humidity change. Again, that's still pretty vague, but that's better than it was before. A heater and humidifier will be used to change the environment. So it tells me my test setup along with what I expect out, which is output on the screen that shows differences in the environment. So it should show a difference between one heat and a different heat. Design a device. Again, no, not a clear deliverable. Learn the basics to programming the MSP 430 MCU by blinking onboard LEDs. Again, no, that's not. Learning and educating yourself are things that is not an outcome and a deliverable. Where the blinking onboard LEDs is a deliverable, but that's not really 100-hour intensive work. Hardware prototype of oscillator circuit that operates with a power source input and produces frequency output. Again, this is still not quite acceptable. So think about ways that you can improve that. Hardware prototype of oscillator circuit that operates with a power source input and produces frequency output. So we could change this so that we have more information here. So again, what is that test environment? Is it going to be tested one time? What kind of frequency range am I looking for? What kind of power input? Is it just from the wall, or am I building that power supply? So more details is better so that it's very clear what your deliverable is. So the other parts of the project overview, one is that background research. Make sure that you're investigating existing solutions. If you need to, you could even reverse engineer, which means to take apart something and look at it and actually reverse engineering it. Read books, articles, etc. Make sure to use that online resource through the Marriott Library. They have got a great database. IEEE Explorer is a very common one, but if you put in a topic, it will bring up a lot of different articles and journals and books on that specific topic. So you don't have to go to a specific database, but it will incorporate all of the databases such as IEEE Explorer, Scopus. You can also even just browse. You can also ask questions to guide your research through an assistant at the library. So make sure that you're aware of those resources and take advantage of those too. While you're doing your background research, thinking about a couple other things such as defining a need, design criteria, preliminary designs, prototypes, and then knowing that you're going to be iterating this again and again. The other area of the project overview that I wanted to give examples about is that solution that I mentioned, a high-level block diagram. So this is an example of one such high-level block diagram. You can see here that it has multiple okay, there we go. Multiple parts to it. You have this grid to coil power electronics. It has more detail in that there's an AC to DC rectifier, DC to AC. It's going to be using these wireless power transfer coils. And then it has the coil to vehicle power electronics and some more details about what is actually inside of that. Up here for the master control, it goes into a little bit more detail on that. It's connected to the EV battery, and then on this is connected to the utility lines, and you need a module again for that utility line. So a lot of research and investigation went into this before this solution can be created. So when I see something like this, I know that somebody just didn't sit down and do this in 5 minutes. I know a lot of effort and time went into creating this type of a solution, because you have to know a lot to be able to even create this solution. The other part of this is to divide up the solution into areas where each individual on the team has one specific target that they are responsible for. Even though everybody's working together as a team, each individual should have an area of emphasis that they focus on. And so this next one goes into more details about who is doing exactly what within this. So one person is in charge of doing the car side and the grid side coils for that wireless power transfer. Another person is going to take over the grid side power electronics, and then another person is going to do the car side power electronics, and then another person is doing that grid side power electronics. So each of them has their own area they're in charge of, and then it goes into a little bit more detail as far as how they're interacting together. You can also do this on the diagram itself. You can just, highlight this area and say, this is, Dustin's area. Down here, this part is going to be responsible by whoever else, Tina, in the project. So that's another way you can highlight who is doing what and whose main responsibility is where within the solution. This is another block diagram solution that you can tell, again, took a lot of effort and understanding of the project itself to be able to create such a block diagram. So making sure that you do enough research to be able to create such block diagrams. I tried to make this one a little bit more anonymous, where one person had the assignment that their main focus was going to be the analysis of the lead acid batteries. Another was focusing on the hardware itself. Another person was looking at the Python analytics and analyzing that with the Raspberry Pi device networking. And then one other person was on this team, and they developed the user interface and Bluetooth networking. So each person had their own assignments and worked together to create the working solution at the end. Another example of a higher level block diagram. In this case, this was a 2-person team, and one person kind of took this area here and did these steps, while another person in parallel to them did these steps using a different environment. So they analyzed different environments, kind of did different steps to achieve the same end result, and did it in different ways. And then at the end, they compared to see which one was going to be the optimum solution. So that's another way that some of you may be doing it, is to create similar end results, but doing it in different ways and then comparing those results to see who had better end results. A breakdown of another person's project was that these 3 individuals broke this down. One person was doing active system, one other one was doing a passive system analysis, and then one person focused specifically on a LabVIEW interface and gathering all of the data for these different types of systems. So that concludes kind of these examples. Let me know if you have any questions.